Hi students, welcome to the next lecture of electronic measurements and instrumentation. Today we will see the concept of data acquisition systems. My name is TSS Nagapavan Kumar. So now we are discussing the concepts of Unit 6, where this Unit 6 contains measurement of physical parameters and the collection of this data from the different places. Okay, so that is the data acquisition system. So here, what is this title of this topic? Data acquisition system. So we know the system. A system is a group of components which will works for a specific application. It has some inputs and it has some outputs and it has some processing information. Now coming to here, this data acquisition system, what these systems are going to processing, or the data acquisition systems are going to what is processing here. Okay, so coming to here, it is processing data. It is processing data. What it is doing, it is acquiring. It is acquiring the data. So from the different locations, different types of data. First of all, it is collecting, and it is giving to some output. So we said that a system. The system will collect the input. Input is different sources of data, and output is different types of outputs. So what are the inputs? What are the outputs for this type of system? Is the today's class. Okay, in the today's class we are going to see the systems of DAS, data acquisition systems. DAS, we are calling simply DAS. So this DAS systems is collecting some information. So which type of information it is collecting? Our unit is completely physical parameters measurement behavior. So for the reason here we are collecting non-electrical information, that is physical information we are collecting from this for this DAS systems, and we are giving the output for this from the system. For the system we are giving to the output as for the printing purpose, or for the displaying purpose, or for the transmission purpose, or for the controlling, for processing, whatever it may be. Whatever the output you require. Analog output you require, we will give analog output. If you require digital output, we will give the digital outputs. So this is about the DAS systems. This is about the DAS systems. Next, coming to that, data acquisition systems are DAS. Okay. So what is the basic definitions for these all of these? Data acquisition system is used for data processing and data conversion, data transmission, data storage. See here, what are the operations are there? Data acquisition systems we are using for data acquisition systems we are using for processing. Data acquisition systems we are using for first processing, next conversion. Data conversion from analog to digital, digital to analog. And processing means if you want to amplify the signal, you can we are doing some signal conditioning operations. That is comes under category of processing. Next, transmission. So from one location to another location, we are transferring this data by using different types of communication medium. It may be air communication, it may be wire communication, it may be any other type of communications. Next, coming to that, storage. So whichever the data you are receiving, that is you are storing the data. So this is the data acquisition systems major important role. Okay, so these are these four operations we are going to see now. So based on this, you have to try a block diagram. What is the block diagram of data acquisition systems? Now based on these operations, now you have to form. You are the student almost completed the graduation program, undergraduation program. At this stage, you have to design a block diagram based on its working. So what is its working? Processing of data, conversion of data, transmission of data, storage of data. These type of operations we have to perform. So for that reason, you have purpose you have to draw the block diagram. Okay. Anyhow, let us see. If you want, you can try by passing this video. After that, you can continue the video. Otherwise, see here. Next, the digital data acquisition system consisting of sensors with the necessary signal and display system. So this type of data systems is consisting of sensors. What is the purpose of sensor? Collecting the data. So for that reason, for data acquisition purpose, we are using sensors. Next, with the necessary signal and display system. For displaying these behaviors of these sensors, we have to establish some monitoring or display systems in this DAS systems. Next, DAQs are used to convert analog waveforms into digital waveforms for processing. So here what we are doing, we are converting analog to digital conversion operation also. Here we are converting the analog values into the digital waveforms. Analog information we are converting into the digital waveforms. Data acquisition applications are controlled by software programs developed using various general purpose programming languages such as BASIC, C, Fortran, Java and Pascal. So as per the textbook we are seeing these type of software languages, but in the present days we are using Python programming for controlling these type of devices. We are using different types of IoT related softwares for controlling these devices. We have very advanced data acquisition systems with compared to the traditional data acquisition systems. But as per syllabus, we have to see the basic data structures, basic data acquisition systems. So, with compared to this data acquisition system, in the field we have more advanced data acquisition systems. At that time, they have used basic C, Fortran, Java and Pascal languages. Presently, we are using .NET, like Java.NET, C#.NET, otherwise SAP we are using, otherwise Python. We have a lot of advanced softwares. Those are the softwares we are using for controlling all these devices. Next, coming to that, now we will see the block diagram of data acquisition system, the generalized block diagram of data acquisition system. So in this, first collecting the information, first collecting the data, here we have to take the transducer. Transducer 1, transducer 2, transducer 3, transducer 4. Here I am taking four sources of data. I am taking four sources. Okay. So transducer 1, we can keep it as a photoelectric transducer or maybe piezoelectric transducer or strain gauge or resistive or inductive or capacitive or LVDT, or we have lot of transducers. So in that you can select any four and you have to keep here. From this transducer we will get some electrical output. So the transducer has some non-electrical energy as an input and the transducer output is electrical energy. From this electrical energy which is coming from the transducer, we are processing by using signal conditional blocks, So what is meant by signal conditioning? Signal conditioning is nothing but as processing the signal data like pre-amplification, post-amplification, or different types of amplification stages we are keeping in this signal conditioner. The purpose of signal conditioner is to improve the input signal. That is, the input signal is, if it is a weak signal, we are amplifying the signal. And at the same time, if you want to take the printout of this waveform or the input signal, you have to amplify the signal to take the printout. That means the printer needs some energy. It may be 20 volts, 30 volts, 40 volts. But the signal may be 20 to 30 millivolts. First, we are pre-processing the data, that is pre-amplifier. We are using the signal conditioner pre-amplifier. This pre-amplifier, first the weak signal is going to be amplified. That is 20 millivolts is converting into the 5 volts or 6 volts signal. After that, if the signal has to be taken by the printer, then again it is amplifying the signal. From the pre-amplifier output, it is taking the signal. The post-amplifier, it will amplify up to 30 volts, 40 volts signal. Like that, the signal conditioner will work. Right. In the here we have the complete input data in the electrical form with a good amplification levels. Now, at the output of the signal conditioners stages, we have the data perfectly. Okay. Now, we are giving this information to a multiplexer. Why? Because 4 transducers information we can't see at a time. If you want to see at a time, you have to use 4 output devices, 4 printers, 4 displays. But we are going to keep a single monitor. We are going to keep a single printer. But singular printer, the printer has to take any one of the information, then it has to process the printing operation. For the display purpose also, the system has to collect any one of the information and it has to show one input signal at a time. Okay, so for that reason, at that time we have the multiplexers. So see here, up to here, we are dealing all the signals in the analog form. Okay, output of the transducer is an analog signal. That analog signal we are amplifying by using the signal conditioner circuit. So this analog signal we are giving to the multiplexer. Now this multiplexer we can call analog multiplexer. This multiplexer is dealing with the analog signals only. Now what is the multiplexer operation? Multiplexer operation is nothing but as selecting any one of the input signal and it will passes to the output. Actually, the multiplexer has multiple inputs, only one output. As per we know the digital electronic circuit, in the digital electronic circuit we said that MUX multiplexer has many number of inputs. It has single output. So here we have 4 inputs and here we have only one output. That output is nothing but as any one of the input signal based on the selection wise. So the output of the multiplexer is any one of the input signal, Either transducer 1 output will come at the output of the multiplexer. Otherwise, transducer 2, any one input signal only available at the output of the multiplexer. That is, the multiplexer is nothing but as a selection switch. Any one of the input signal is connected to the multiplexer, not all the signals. Now, from this multiplexer, we have only one output. The output here we have the availability. Now, if you want to a digital signal, the output signal you have to convert it to digital. For that reason, you have to use an analog to digital converter. For that signal, you have to use an analog to digital converter. Right? So, the multiplexer output, we have the analog signal. After the multiplexer, I have used an ADC, analog to digital converter. This ADC signal converter will give the output as digital output. Okay, let us see the next one. So the analog output. So here we have the analog data, and by using ADC, we have the digital data. So whichever the signal you require, you can use for the generating the outputs. So the analog output, if you are for the printer, if you want to give the analog data, you can give the analog data for your printer. Otherwise, if you want to give the digital data for your printer, you can give the printer. So see here, multiple outputs are available. We can print this data by using a printer. Otherwise, we can see the data by using a display. Otherwise, you can store this data by using some magnetic memory. Or you can transfer this data from here to another area by using the transmission block. And the last one, you can do multiple operations on this signal. That means you can use a computer processing unit. Okay, this signal, if you want to compare with another signal, you have to do some data processing, digital signal processing operation. Those are we are performing by using computer processing block. Okay, this is the total structure of a block diagram. See once. Here, the first stage is transducer. The next stage is signal conditioner circuit. Next stage is multiplexer. From the multiplexer, we have analog data, digital data. The analog data we are taking directly. For the digital data, we are using an analog to digital converter. After that, finally, we have a printer, display, magnetic memory, transmission of the data, and computer processing data. So these are the different types of outputs are available here. Okay, next. So coming to that, we have different types of blocks in this block diagram. Then how to design these blocks? What are the characteristics for these blocks? What are the factors for these blocks? That means what is about their efficiency? What about their signal to noise ratio? What about their CMRR ratio? These are the parameters we have to discuss. So coming to here the factors, the important factors to decide the configuration and the subsystem of the data acquisition system are follows. If you want to design a perfect data acquisition system, you have to see some of the important parameters for these systems. The first one, accuracy and resolution. It should possess a good accuracy and resolution. Next, number of channels to be monitored. How many number of input signals you can connect for this device, and based on your requirement you can see any type of data, but the connectivity is very, very important. How many number of inputs you can connect at a time, that is very important. There is number of channels to be monitored. Third one, analog or digital signal. So if you want the digital output, you have to use an analog to digital converter. Otherwise, if you require analog signal, there is no need of using ADC converter. With this, we can reduce the cost of the system also. Sometimes you can remove unnecessary works from the system and you can reduce the cost. Next, single channel or multi-channel. If you have only one source of the data, you have to use a single channel data acquisition system. If you have multiple inputs of your data, then you have to use multi-channel data acquisition system or multi-channel DAQs. Next, fifth one, sample rate per channel. Per channel, for example, if you want to see this information with very fast of response, that is the speed of response if you need very high, then you have to use the sampling per channel. Correct sampling, the suitable sampling is very important for each channel. Next, sixth one, signal conditioning requirement of each channel. For we have different types of inputs of data. For each input, which type of signal conditioning circuits are better, you have to choose. Next, seventh one, cost. While designing all these parameters, you have to check the cost parameters. So these are the factors are affecting. These are all of the factors are affecting for designing the data acquisition systems. Next, various general configurations of DAS. The DAS seems to be like either single channel or multi-channel. In the single channel, possibilities direct we can convert data without selecting any inputs, pre-amplification and direct conversion, sample and hold and conversion. Here we have S and H, that is sample and hold circuit is available and conversion is also available. If you have only single input data, there is no necessity of taking the decision. You can directly process the data. Pre-amplification, signal conditioning and other any above you can perform. Next, coming to that, multi-channel possibilities. First one, multiplexing the output of a single channel converters. In the single channel data acquisition system, there is no necessity of using multiplexer. But here you have multiple channels, so for that reason you have to use a multiplexer, okay, for converting that data individually. Multiplexing the output of the sample and hold circuit. At the output side, we have to use sample and hold circuits. Multiplexing the inputs of sample and hold circuits and multiplexing the low level data. So these are almost we have to handle this multiple data. These are the major blocks in the multi-channel possibilities. Now we will see individually the block diagram of single channel, multi-channel. So let us see. This is the single channel data acquisition system. In the single channel data acquisition system, here we have the input. We are using the analog to digital converter. From this analog to digital converter, we are giving buffer and directly we are giving to the computer output. Here we are using a convert command. Okay, just we have to give the start command. So when you are giving the start command, the output of the transit user will be applied to the directly analog to digital converter and it will give the output through the buffer. So this is a very simple concept. This is a very simple single channel data acquisition system or DAS. Single channel data acquisition system. Next, multi-channel data acquisition system. In this multi-channel data acquisition system, see channel 1, channel 2, channel 3, channel 4. That is, here we are taking analog signals, analog signal 1, 2, 3, 4, which are we are collecting from the collecting from the transit users. From this here, the next step is scaling, amplification, signal conditioning. These four blocks are for the four inputs. Where these four input signals we are doing here: scaling, amplification, and signal conditioning operations in this stage. This is the second stage. Now coming to the third stage. Here we have the multiplexer. I said that at the output of the multiplexer, we are using sample and hold circuit for selecting the number of samples per channel. So see here, at the output of this multiplexer, we have S and S by H, that is sample and hold circuit. From the sample and hold circuit, we are connecting to analog to digital converter. From this analog to digital converter, we are giving to the buffer. From this buffer to, we are taking the data. Right, where the single channel gives the data without very heavy usage of hardware, but the multi-channel data acquisition system using a lot of hardwares to select a particular input and to process the selected input perfectly. So this is the additional circuitry blocks we required for multi-channel multi-channel data acquisition systems. Okay, note it down this one also. You have to note it down the single channel and the block diagram and this one. Totally 3 diagrams you have to note it down. Next, objectives of this data acquisition system. Already we have seen what is the work of our data acquisition system. Once again we will see the objectives of the data acquisition systems. Acquire the necessary data at correct speed at the correct time. So what is it saying? We have to take only necessary data with good speed and with within correct time, within time. Okay, that is very important. Second point, use of all data efficiently to inform the operator about the state of the plant. So what here all the sensors we are keeping in an industry, in a plant, and the plant behavior we can observe using these data acquisition systems. So for that reason, all these sensors has to respond immediately, and we have to give the controller or operator who is there for that plant. Then only he will control all the informations and he will save the department in time if is there any problem. Next, it must monitor the complete plant operation to maintain online, optimum and safe operations. So we have to provide a compulsory monitor we have to provide a display unit for monitoring all the activities, what are the things are happening in that particular plant for getting the better production. It must be able to collect. It must be able to collect, summarizes and store the data for diagnosis of operations and recording purpose. Okay, what are the operations today we did, and what are the operations we did at the 10 days back or 1 month back or 2 months back? We have to check once again after some time. Okay, so every month we have to check the processing stages. So for that reason, we have to store this data. You have to collect the data, you have to summarize the data, you have to analyze the data, and you have to store this data. So these are the objectives are there for the data acquisition system. It must be flexible and capable of being expanded for future requirement. For future requirement, which type of requirement you require in the future you don't know. So for that reason, future requirement purpose we have to save this data perfectly, and you have to design the system in that way. It must be reliable and flexible. It should be reliable, flexible, and it should work for a long time, and it should give a better efficiency. These all of the things are very, very important for the data acquisition system, that is the DAQ systems. And now coming to the applications of this data acquisition system. We have a lot of applications. In many industrial applications, mechanical quantities like temperature, pressure, flow, velocity, and so are measured. Wherever you want to measure the temperature or pressure or flow or velocity or moisture or humidity or proximity, whatever the parameters you required, so you have to measure all the parameters in the mechanical industries or electrical industries or electronic industries or anywhere. At the places you have to use this data acquisition system. In robotic, tactical and manufacturing applications. So most of the today industries are automated industries are available. So all the works are doing by the robots only. Okay, in the critical situations, all the robots are working perfectly. So if you want to know how the robots are working and how the robotic operations are controlling, or how the automobile industries are working, we have to use this type of data acquisition system. In control systems, when motion feedback is employed, whenever the motion feedbacks be required, at that time we have to use this data acquisition systems. In process of testing, monitoring, diagnosing application, wherever the testing, monitoring, and the diagnostic applications are available, we have to use this data acquisition systems are perfectly. Engineers and scientists in nearly every industry use data acquisition system. Almost all data acquisition systems, DAQ, we can call DAQ or DAS, both are acceptable for validating and verifying a design prototype, teaching in the university lab, diagnosing a machine malfunction, or controlling the manufacturing process, or whatever it may be. We have multiple applications of these type of data acquisition system, DAQs or DAS. Okay, these are the very, very important applications. Okay, with this we have completed the concept of data acquisition systems. Okay, thank you.